Equations. And what does that mean when you see the word equations?
Equal.
You have something that is equal to something else. So basically, the idea that we learned yesterday is that when you have an equation, you start with the answer, then do the opposite of whatever the problem tells you to do. And that goes for the order of operations too. Usually you have to multiply and divide first, correct? But when we're going backwards, we always do the opposite. So instead of doing multiplying and dividing first, you do adding and subtracting first. And then you do multiplying and dividing last. And that's what you did yesterday. I want to look at this problem right here. I want to look at this illustration. That's a 3, that's a 15, and that's an x. Wrong. That is not x. That's x, men. All right, so I want to look at that problem. How would you write this as an equation? There are many ways you can do it. But who can give me a way you can write this as an equation? Yes, ma'am.
15 plus 3 equals x.
Okay, 15 plus 3 equals x. That's one way you can do it. Is there another way you can do that? Write that out? Yes. Another way to do it is x plus 3 equals 15. Is there any other ways you can do this? Yes, ma'am.
X minus 15 equals 3.
You can also write this as x minus 15 equals 3. Actually, this one is not correct.
Which one?
The middle one.
That's all x.
Yeah, because x is all of it. So you're saying all of it plus 3 is going to give you this little piece right here. So instead of plus, what should this be?
Subtract.
Subtract. So you look at that, the whole thing, and you take away 3 gives you that 15. All right, so 3 different ways to write out the same thing. What is x equal to in this case?
3 plus 15.
3 plus 15, which is what?
18.
18. Now if I look at this, what do I have to start with?
15 minus 3.
I have to start with the 15, but then what do?
Equal.
You have to do the opposite to give you 18. All right. Here again, if I start this, I start with the answer, which is
3.
and then I add
15.
15, which is 18. So 3 different ways to write the same exact thing. And it gives you the same exact answer. Now I'm going to ask you this. In this problem, how do we know? Like here, we didn't do the opposite, did we?
No.
It said plus, so we added. Here it said subtract, so we added. Here it said we subtract, so we added. Why is it for these problems we did the opposite? But here, you didn't do the opposite. Yes, sir.
Because the x is a total.
But my question is this. Why do I not do the opposite here, but I do the opposite here? So I'll say this. It's not, you don't do the opposite. But here, you do the opposite. Yes.
It's backwards. It's like turned around.
Explain.
So whole point is to find x.
Uh-huh.
And that they're trying to find the.
Excuse me, I just burped on camera. You probably heard that here. Sorry, continue.
Because they switched it around. So
They
instead-
switched it around? Okay. Meaning what?
So
Like,
instead of trying to find x, they're trying to find 15.
okay, so I think this is what you're trying to say. If you look here, the x is by itself, isn't it? They gave you the x by itself. Here, the x isn't by itself. It's mixed in with something. So the idea is this. If your letter is mixed in with something else, you'll have to do the opposite. There are some exceptions to that, but there are a few, and we'll go over those exceptions today, actually. Yes?
So if it's like, so if the letter is with another number,
Mm-hmm.
you do the opposite.
Yeah, you do
But
the
if it's
opposite.
not, then you don't.
Kind of, yes. And I'll show you some examples where it's not true, but let's just stick with this. When you're doing the opposite, you look at that. That says minus what?
3.
This says minus what?
15.
So you did the opposite, which was that, which is that. Now, let's look at this next example over here. We have this. It's the same idea. Now we have it that way. How could I write this as an equation? There are, again, 3 different ways like we did over there. Yes, sir?
7 minus 4 equals x.
All right. 7 minus 4 equals x.
So x equals 7.
4 plus x equals 7. And there's one more way. 7 minus x equals 4. All right, good job. Now to do this problem, x is by itself, right? So it just says 7 minus 4. So it's pretty simple. You just do whatever 7 minus 4 is, which is 3, yes? So we know that x is equal to 3. Now right here,
It's in the equation.
okay, we switch it around. So in this case, but what does it say we're adding here? We're adding x. So you may have learned that it doesn't matter what order you add in, you're still going to have the same answer, yes? So you can really rearrange this and write it as x plus 4 equals 7. And then you just do like you said. You do 7 and minus 4, which is equal to 3. I'll write that down here. So thing is, this answer has to be 3, doesn't it?
Yeah.
Now, but if I were to do this, what does this say to do?
Subtract.
Subtract what?
X.
What's the opposite of subtracting x?
Adding.
Oh, but we don't want to add x, do we?
No.
Ah. So it's kind of tricky.
Switch it around.
Switch what around?
X and 7.
Unfortunately, you can't do that. I mean, you can switch it. Think of that's a positive 7. If you were to switch it, you'd have to rewrite as minus x plus 7 equals 4. Because it says minus x. It doesn't say minus 7, does it? And remember, when you switch these things around, you got to keep this with that. I did that over here. It's like saying that's a positive 4 and a positive x. Well, I still have a positive 4, and I still have a positive x. Now I look at this thing. You can do the opposite again. You still can do, in this case, this says what? What?
Plus 7.
Plus 7. So you start with the answer. What's the opposite of plus 7? Minus 7.
Equals
What's equals not x? It equals minus x. You got to keep that minus sign there. That's kind of crazy, isn't it?
Why is the equal sign on the other side?
Because I just wanted to put it there. So let's write it this way. Minus x equals 4 minus 7, like that. What's 4 minus 7? You have $4, but you owe somebody $7. I have $3 now?
No. You gotta add the X.
I'm in debt $3. That means I still owe $3. And this is getting complicated, isn't it? Let's make it simple. Now, we haven't gone over positive and negative integers yet, have we? No. So it's going to be a little complicated. So let's not do it this way. This is kind of complicated. So let's just make it nice and simple. Whenever you see something like this, a minus x, what you could easily do, switch that. So this becomes 7 minus 4 equals x, which is what we did right over here, isn't it?
Yes.
So right here, when you're subtracting x, just switch that with the number on the other side. It'll save you a lot of work. And then x equals 3. So this is kind of like a special case. When you're taking away the letter, just switch these two guys and then do whatever it says. Okie dokes, artichokes? That's 15. That means this is 15 and that's 15. Now, how could I write this as an equation? There are a few ways you can do it. Yes?
15 equals X.
All right, you could have 15 times 3 equals x. Yeah, because this whole thing is x, and you're cutting it into pieces.
Yeah.
And cutting into pieces means to do what? Divide. So you're cutting up this whole thing into 3 pieces, and that means 1 piece is equal to what?
1 piece is equal to 15.
15. So if I do this, is x by itself here? Yeah, so we just do what it says. What's 15 times 3?
20, 30,
What's 30 plus 15?
5.
So x equals 45. That didn't. X equals 45, which makes sense. 15 plus 15 is 30. 30 plus 15 is?
45.
All right, so you can see that in the picture. Here, is x by itself?
No.
No, so we do the opposite. We start with the answer, which is?
15.
And this says to do what?
Divide.
By?
3.
And what's the opposite of dividing by 3?
Multiply.
And we already said 15 times 3 is? All right. So the way things are written are very important. I want you to keep that in mind.
Yeah.
You might like this video.
Hi.
This is my last video. Or just hit the little circle right here for the subscribe. Have a nice day.